What's going on, everyone? Welcome back to the channel. In this video, I'll be showing you how to use this cool new sensor I just received, and it's a HC-SR04 with built-in RGB capabilities. As you can see in this video above, what I'm doing is I'm changing the color of the built-in LED sensors based on the distance. And it's pretty cool that you can do this and add pretty much a visual effect to your projects, which you can't do with the standard HC-SR04 ultrasonic sensor, which happens to be also a very popular sensor. So I think this is a beautiful touch. And what's also nice about this sensor itself, it uses a really nice standard, the WS2812 LED standard that you can easily use to change any of the onboard LEDs for this device. It has 6 onboard LEDs, so I'll be talking about how to change the color, what I did to go through that in the code, and we'll just be showing another demonstration here. As you can see, I'm altering the color of each LED randomly. It's not really that clear in this video, but if you look close, you can see inside of the sensor that the RGB colors are changing, which is pretty cool. So there's a lot more you could do here with this touch. I think it's a great sensor to buy to have some fun in your projects. And I just want to show everyone how to do this because there's almost no documentation to this online, and it's a relatively new sensor. So that being said, let's just jump straight into it. Okay, physical setup for the sensor. We only have 5 pins. 2 of them are corresponding to ground and power, so that's pretty straightforward. If you worked with sensors before, you should know that. Also, the other 2 pins are echo and trigger, which correspond to the regular ultrasonic module. This works exactly the same as it would with the regular HC-SR04, which I have a video of on my channel, and there's many videos online of how to get that set up. But the main thing you want to focus on here is the RGB in. So I just plug that to GPIO 28 on the Raspberry Pi Pico W, and you can plug that into any GPIO pin you want. And that's pretty much it. Okay, so I have this code here that I wrote myself, most of it, but the library I found mostly online. I did a slight modification to get it to work with the Raspberry Pi Pico W, but this is essentially just a really common Neopixel library used for the WS2812 standard, which allowed me to trigger the RGB LEDs from my device. And that's pretty much all you have to know about it on a high level. And I access this library to access the RGBs in the device and change their color, change their brightness, etc. So that's pretty cool that I found that online. And I'll link where I found that below, and I'll link the modified one to my GitHub repo below as well. So this is the code I used that you guys saw in the first 2 videos of this. The first 2 snippets of this video is this whole code right here. So the first thing I ran actually was change color with distance. So this is pretty cool because it combines the ultrasonic module with the RGB module. So what I did was I wrote this helper function called getDistance, which uses the HC-SR04 ultrasonic module to calculate the distance, which I have another video. And once again, you can find how to use that online. And every time I calculate the distance, I change the color corresponding to the threshold of the distance. So if I find that my robot or my sensor is really close, I change the color to red. If I find that it's moderately close, I change it to yellow. Anything outside the 20 centimeter range, I change to green. And then what I did in this for loop here was I set all of the LEDs to the same color, because we have a total of 6 LEDs, and you can actually change each LED individually, which is pretty cool. So you can see I set the colors up here. I just set some standard colors: yellow, orange, green, blue, red, lavender. You can set whatever you want in terms of the RGB values. I just did those for simplicity's sake. And you can see I set the number of pixels as 6 because I have 6 LEDs on board, and then 28 for GPIO 28. 0, you don't have to worry about this too much. You can read what this value is in the documentation of neopixel.py. That's actually just the state machine, but we're not going to get into that. And then the other snippet I showed you was fun. So that has nothing to do with the ultrasonic module. I was just randomly altering the colors of the 6 RGB LEDs on board every 0.5 seconds. So what I did was I just got a random number corresponding to an LED number, and then I got a random color, and I tied it back to my dictionary, and I printed the random LED and the color, and then eventually I just set the pixel to that color. And that's where you saw in the second snippet where it was changing color pretty nicely, and it looked pretty cool. So that's pretty much it. You can really go a lot of ways about this code. This is just a really simple way to show you at a high level what this module can do. I think it has nice applications in terms of the combination of the ultrasonic and the RGB. Maybe in a dark environment, you can color the environment, light up the environment, and also as I showed here, you can have some sort of like visual indication as to whether an object is close or far away, because the only other way you'd be able to visually tell if it's close or far away is looking at the code and seeing the value it's giving you. Whereas in this case, you know your robot's within a certain distance based on the color of the sensor. So that can add another sort of more help to your applications in terms of like being able to understand what's going on. And it could also just look cool in general if you want to have a nice, interesting looking robot. I think it's a nice touch in general. Overall, it was kind of difficult to find to get this to work with the WS2812, but thankfully the guys on Raspberry Pi, the guys and girls even on raspberrypi.org, I asked them how to sort of access LED modules. They were able to help me really nicely there. So I just want to thank them especially. And I want to thank everyone for watching this video. It's always a pleasure showing people new sensors, showing people easier ways to get their code set up and just make things more efficient for everyone. So if you did find this video useful and you thought the sensor was pretty cool, please like, comment, subscribe. Let me know what you want to see in the comments below. And generally for this video, if you have any questions about the sensor, if you're interested in the module I use, anything about the code, please let me know in the comments down below. I'm really quick to respond. So I would really appreciate it. And that being said, guys, just thanks for watching. Take it easy as always. Take care.